All right, so I am not in class today. As you can see, I have other things I am doing. So I wanted to give you guys this video so you guys could fill in some notes while I'm gone, and then we can circle back and talk about them on Monday. So when we are looking at 3B, we see that's about function notation. And so we've talked about function notation already, right? We did that in Unit 1, talking about input values, mapping to output values, how to use the intersect to solve backwards for input values. We're just going to be getting more practice with that here and here. Just those are really critical skills, so we're going to hit them one more time. And we're going to kind of include some new, some new perspectives. So like some more difficult functions and some moments where you might need to evaluate several functions. But generally, when we're talking about function notation, we're working on it. I kind of talked about 4 different cases we might be dealing with. The most straightforward one is where we have a function and we have a specific input value. So for example, here we have f of x is equal to 3x squared plus 5x minus 2, and we're trying to find f of 5. We're trying to find the output when the input is 5. So to do that, we're just going to, everywhere we see 5, or everywhere we see x, we're going to replace it with 5. So that's going to become 75 plus 25 minus 2, going to become 98. And for some other functions, you might want to plug it into your calculator. So for example, we have the height of a football after being kicked is modeled by this equation. And we want to try and figure out the height of the football 2 seconds after it's kicked. So we want to evaluate this function. We're essentially trying to find h of 2. And to find that, I am going to plug in 2 into my formula over here. So I can do that in the calculator. We can do negative 4.9 times 2 squared. And then we have plus 30.2 times 2. And we see that the height is 40.8 feet after 2 seconds. So 40.8 feet. Make sure I did that math right. 49 times 2 squared, or negative 4.9 times 2 squared plus 30.2 times 2 seems reasonable. That's easy enough to do. But the thing that I want you to consider, which you do not need to do, you can take it the long way, but sometimes it might be worth your while to use the value function on the calculator, where you put it in y1 and then you use the value command. So an example where that might be useful is if you have a complex function and you need to plug in multiple values. For example, the number of visitors to Provincetown throughout the year is modeled by the equation, this whole quadratic there. Not a quadratic, it's a quartic polynomial, actually. Where v is the monthly visitors and x is the month of the year, so ranging from January being 1, 2, 3, 4, and so on. So we want to try and figure out how many visitors there'll be to Provincetown in May, June, July, and August. Well, that would entail finding v of 5, v of 6, v of 7, and v of 8. And so you could certainly plug in each of those numbers in for x individually and solve it out. But if you want to take a slightly less time-consuming approach, you can instead choose to type the whole function into, let me get my calculator to do what I want it to y1. So we can do 12.7 times x to the 4th minus 361 x cubed plus 3,220 x squared minus 9450x and plus 7430. Okay, and so the benefit of typing in the whole function there is now that when we want to find the specific values of it, we can go second trace value. And then we can just type in the value we want. So if we care about May, we'll type in 5, and we see that that brings us to 3,490. So 3,490. If we care about June, well, then we'll just do that again, and we'll type in 6 instead. See, that's 5,130. If we care about July, well, then we'll do that again, but we'll type in 7, and that is 5,730. If we care about August, well, then we'll do that one last time, and we'll plug in 8. That'll be 5,010. Nope, 5,100. Let me get my rounding right. 5,100. So what I'll ask you to do now is use your calculator to evaluate these two functions at these different points. And you can explore, if you want to save some time, plugging them into y1 and using the value function, or just straight up plug them in and do the math, whatever is more comfortable for you. So that's the first case. The first case is where we have an input value and we want to locate the value of the output value. The second case is the inverse of that, which again we talked about before, and that is where you have an output value and want to solve backwards for an input. So we have our football here, but now we care about how long does it take to reach a height of 30 feet off the ground. So what we can do there is we can take our function, put it into y1, and now when we hit graph, hold on. That should be a plus. Now when we hit graph, we can see that we don't have a great look at it. Sorry, and then in y2, we put the value that it should be equal to. So in y2, we put 30, because we're trying to figure out when will it reach 30 feet off the ground. We hit graph, we see that we don't have a good look at it. So let's change our window. I'm going to change my y max to be 50. And you see that's a lot better. And so now if we want to figure out where the football, like how long it takes the football to reach that height, we do second intersect, and we go over there, we hit enter, enter, enter. We see it takes 1.24 seconds. 1.24? Yes. 1.24 seconds to reach that height. Okay, now we have a goat population on an island. Can be modeled by the equation 252 times 1.15 to the t. I'm trying to figure out how long will it take the population to surpass 1,000. So this is one where we can go here, 252 times 1.51 to the x. We put 1,000 here. 1,000 here. And then we're going to need to change our window to make this visible. I'm going to say maybe we leave it at 10. We'll see what happens. And we'll change this to be, I don't know, 1,100. So it looks like I want a little bit more on my x value. So I'll go to 15 instead of 10. Generally speaking, for the maximum y value, if I know I want to find where it surpasses 1,000, I'll go a little bit above 1,000. So that way I can see the intersection point, right? That way my line where y equals 1,000 is in my frame of reference. And then we just want to use intersect to find the value of that. All right, so that is 9.86, meaning that is going to take 10 years to surpass. All right, so now what I want you to do, pause the video, try and answer these questions down here, and we can compare answers when we get back on Monday. All right. And then over here, we have both an input and an output. Sorry, so that was the first. So the first case is you have an input, you need an output. The second case is you have an output, you need to work backwards to get an input, and that's where you use the intersect function. The third case, and this is going back to unit 1, is you have both the inputs and the outputs. but you don't have the function. So you have a set of inputs and outputs, and you need to work backwards to find the function. So for example, here we have the function f of x is equal to ax plus b, for which f of 2 equals 1 and f of negative 3 equals 11. And we want to figure out what is our function, like what are the values of a and b here that make this true. And so the way that we're going to do that is we plug in our y for f of x. So it's going to be 1 is equal to a times 2 plus b, right? When we plug in 1 for x, we need to get, or when we plug in 2 for x, we need to get 1 as the output. And when we plug in 11, or when we plug in 3 for x, when we plug in 3 for x, negative 3 for x, we need to get 11. So that means we end up with a system of equations. It looks like 2a plus b is equal to 1, and negative 3a plus b is equal to 11. And then we need to just solve that system, which I recommend you do using the matrix on your calculator. So you can go edit. We want a 2 by 3. And our coefficients are 2, 1, 1, 2, 1, 1. And then we also have negative 3, 1, 11. So negative 3, 1, 11. Okay. And now we can go second matrix, math, go down to RREF, second matrix, the one that we were just looking at. And now we can see that A is negative 2 and B is 5, meaning that our system is, or our equation is f of x is equal to negative 2x plus 5. All right, so I'll invite you to do the same thing for this one here. So we have a plus b divided by x. So get your practice in plugging in 1 for x and 1 for f of x, and then 2 for x and 5 for f of x. That'll give you two different equations in terms of a and b. And then you just need to solve that system to get your values of a